Good morning and good afternoon. It is great to have so many participants joining this webinar called Step by Step, the Higg FEM Verification Trail, Section 6, Air Emissions. We from Leadership and Sustainability are looking forward to spending the next hour with you. This is the fifth in a series of webinars where we will take you into the depth of the different sections of the Higg FEM, the Facility Environmental Module. My name is Laura and I'm an Associate Sustainability Manager at Leadership and Sustainability. I have the pleasure to assist Aladin Okur in today's webinar and will take over the introduction to the verification trail. Aladin works as Sustainability Manager and Chemical Specialist Verifier at Leadership and Sustainability and conducted more than 30 Higg FEM verifications last year. He will be your verification expert today. We will introduce you to the SAC Higg FEM Facility Environmental Module, continuing with Section 6, Air Emissions. After our presentation, we will have time for your questions. And finally, we will make you an offer and present our team to you. Let me introduce you to the verification trail. The purpose of the verification trail is to give you a better and deeper understanding of the Higg FEM. We will take you through the Higg FEM section by section and make you acquainted with all the requirements. Before we continue on our trail, I would like to give you an overview of the verification process. We have identified 7 simple process steps. First, we have the complete self-assessment. This is where our webinar series strives to support you in. Using the SAC supporting documents such as the How to Higg guide. Second, we have engaged the verifier and provide information on the type of factory, number of employees, use of chemicals in production, chemical level reached, wastewater treatment, and the address of the factory. The third step is to make a self-assessment and also the VFEM available to the verifier. The fourth is the verifier to review the self-assessment and the documents, and also to inform the verifier about gaps or issues beforehand. Then, afterwards, the verifier sends out an agenda ahead of the on-site visit to prepare the facility of how the verification is going to take place. The on-site visit. So here you should be well prepared and familiarized with your assessment and documents. Eventually, it will finish off with a reporting, PowerPoint, and a final call. And also, we will remind you to post the results on Higg.org. The SAC has issued a protocol for on-site verification, which gives information about the verification process. It is also possible to do an off-site verification. Please observe that if you intend to verify your self-assessment, then you need to plan for it early and also buy the so-called VFEM. You can only buy the VFEM until October the 31st. For all of you who are doing your self-assessment or preparing to get verified, here's some very important advice. Appoint a person who is responsible to complete the Higg FEM self-assessment on an annual basis. Read the How to Higg guidance and the verification preparation guidance for facilities. There's valuable information available for you during your self-assessment as well as the verification process. Respond to the questions comprehensively and document all responses. And also be aware of the time needed. It's an intensive but valuable process, and the ultimate goal is to improve every year. Okay, let's get back to our trail. This is the overview of all the sections that are included in the FEM module. Today, we move on to the 6th section, Air Emissions. And now, I would like to hand over to your verification expert of the day, Aladin Okur.
Thank you, Laura. Welcome, everybody. Next to visible smoke, industrial processes and operations also emit other invisible pollutants into the air. These pollutants potentially impact human health and contribute to climate change significantly. The following presentation will explain how to report your air emissions and how to reduce their impacts. So we will also provide you with some examples and exercises. The air emission section begins with applicability questions regarding your production. These selections will direct you to the Higg questions that are most applicable for your facility. For example, you will indicate which processes that may emit air emissions that you have on site. For example, drying and printing, dyeing. There may also be supporting facilities. generators, boilers, and further, there may be sources of ozone-depleting substances such as chillers, refrigerators. Therefore, you need to know your facility's operations perfectly, then choose your operations. Spraying units are also important, and sprayed chemicals are often problematic in my experience. You need to choose in the applicability section if you are using sprayed chemicals. Here are a few examples: potassium permanganate spraying units, footwear assembly units which are use spraying systems to color the soles, softening spraying units in socks production. Before we move on to the next questions, I would like to give you some information about indoor and on-site emissions. Indoor air pollution sources are primary cause of indoor air quality problems. These may be printing, adhesive processes, and spot cleaning. On-site emission is a point source with a stack that emits to outside environment, for example, fuel consumption and spinning or dyeing. We will now guide you through the 3 air emission levels, for which level there are allocated subtopics with corresponding questions. You can see the levels and structures here. Let's now walk through the air emission section, question by question. The first question is: select all sources of air emissions relevant to your facility's operations that are not regulated by a permit or for which your facility is not in compliance with its permits. The intent of this question is to determine if the facility is aware of all on-site emissions to the air. And to achieve this, you need to monitor also air emissions which are not in the scope of local legislations and non-compliances. And an air inventory is needed for the facility to track and manage emissions and their sources. In here, the following elements are suggested to be included in the inventory: the pollutants known or likely to be present, quantity of each pollutant emitted, emissions points, any control devices, frequency of monitoring, compliance with legal regulations. Question 2 focuses on air emissions that result from production processes. Let me explain further these questions because this question is only for indoor air pollution and fugitive sources from production processes, sources without a chimney that emit outside the building. You shouldn't enter your point source emissions in here. You can calculate and track these emissions by using health and safety indoor air quality test reports. But you need additional information. Could you previously slide? Yes, yeah. But you need additional information to calculate annual indoor air emission inventory. You will need airflows of windows or doors, but it's hard to determine in case you. But in this case, you can make an assumption for airflow. For example, total air in your facility changes 10 times a day. So now you have airflow data to calculate amount of air emission you cause. Now you need to multiply the measured concentration with the total volume in the building and multiply with just 10. Yeah, next slide, please. It's suggested to upload an inventory of emissions to air for all sources of emissions from production processes, as well as records detailing how the quantity of emissions reported were calculated. Next slide. Let's make a calculation exercise for VOC emissions calculation from spot cleaners to understand better. Let's assume you have VOC content of is 1 milligram per liter from VOC test report of spot cleaner, and 2018 the facility consumed 100 liter spot cleaner. then you can multiply 100 liter multiplied by 1 milligram per liter. That's equals to 100 milligram VOC was emitted in 2018. Let's make another exercise and calculate VOC and PM particulate matter in dying area. The facility has worked 300 days in 2018. The facility's VOC and PM results are in dying area. VOC is equal to 0.5 milligram per cubic meter, and particulate matter is equal to 0.5 milligram per cubic meter, and the airflow is 30,000 per day. And please calculate the facilities particulate matter and VOC's fugitive emission in 2019. So you only need to do is you multiply 0.5 with 300 with 30,000, and the result is 0.5 million milligram, which equals to 4.5 kilogram per year. And one question covers refrigerants and asks if any refrigerant has been refilled. If yes, then there must be a leak and points will be deducted. And these refrigerants could be air conditioned, chillers, refrigerators, fire extinguishers. There are also questions about control devices as well as questions about going beyond regulatory requirements. Question 4 is related to on-site emissions, and question 5 is related to indoor air emissions. The intent of these questions is to understand if the facility has an effective systems to control indoor and outdoor air pollution. These are examples for controlling devices. For on-site air emissions, dust collector, bag filter, wet scrubbers. For indoor air control, fume hood, solvent recovery, local exhaust ventilations. The Higg FEM air section encourages you to reduce pollutants limits as far as possible by setting 3 levels of limits for combustion devices that emit nitrogen oxide, sulfur oxide, and particulate matter. Accordingly, question 6 asks whether your facility has gone beyond permit requirements to achieve a higher level of air performance in nitrogen oxide, sulfur oxide, and particulate matter. Here you can check your outdoor emissions test results and answer these questions by comparing results with a limit table that you can also find in the How to Higg guide. Examples of how to achieve lower emissions levels are cleaner energy source, for example, natural gas or renewable energy. Air emission control systems and management such as improving efficiency of conversion of fuel to electricity or removal of sulfur from coal before combustion. Furthermore, I would like to give you an overview of certain air pollution control systems, starting with sulfur dioxide control, flue gas desulfurization, dry or wet scrubbing. For NOx emissions, there is the possibility of flue gas treatment, catalytic filter, as you can see, in the picture on the right. Furthermore, next slide, please. Yeah. Furthermore, other air pollution control systems are for particulate emissions, chimney top electrostatic precipitators, fabric filters, backhouses, mechanical inertial collectors, cyclones or multicyclones, wet particulate scrubbers. Let's make a small exercise of how you can categorize the levels of emissions limits at your facility. Let's consider following measurements. Accordingly, which level did your facility achieve? We got these parameters, these results from our air emission test report. So PM is equal to 75 milligram per cubic meter. Sulfur dioxide is 1,200 milligram per cubic meter. NOx is equal to 250 milligram per cubic meter. So according to which level did your facility achieve? So you get this table from How to Higg guide. So the result is level 1 because sulfur dioxide only achieved level 1. So even though both PM and NOx reach level 2. So let's continue with level 3 and the last questions, number 7. Here it is asked whether you have a process for implementing modernized equipment to reduce or eliminate air emissions and indoor air quality issues at your facility. The intent of this question is for a facility to be able to share or demonstrate advanced practices to control air pollutants. If you have already reached level 3, aspirational, then you don't need to modernize your equipment further and can respond yes in here. So modernizing equipment is an effective way to reducing or eliminating air emissions and indoor air quality issues. With this in mind, you can replace equipment, modify existing equipment, and optimize abatement equipment to reduce emissions. And with this, we have came to the end of our emission section. That was our presentation about the Higg emission section. So now let's take some time for the questions. Let me have a look at your questions. Just a second. There is how to know airflow. Yeah. In some facilities, in some cases, the facilities know the airflow. But in here, in case you need to know airflow, you can do just assumption. For example, your facility volume is 1,000 cubic meter, and you can assume that 10 times a day or 100 times a day, your air is your airflow is changing. So your air is changing in your facility. You can you need to also consider your ventilation. But in some cases, there is no any airflow from windows or doors because it's all closed facility. There's only ventilation, and also they do audits for ventilation time to time. They know exactly what air goes from any door or any fugitive point. In highly polluted cities, manufacturing hubs, ambient air quality is poor. Does this mean that the scores on this section will be affected by outside air quality? I think Higg index doesn't consider this case. Yeah, I totally understand you. In some cities, ambient air quality is really poor, but it doesn't. Higg index doesn't consider this point. For ozone depleting emissions, if I'm measuring it yearly, once only it will be valid. Yeah, you need to do yearly. Yeah, absolutely. So how much you add refrigerants yearly, you need to record it. And after we come to your facility, we are going to verify and we are going to check your records. Level 1, question 4 and 5 regarding control devices for a simple cut and sew facility which is out of scope according to legal requirements. Should it install control devices or should it have external third party inspecting the air emission regularly? In my country also it's out of scope, so we do not also suggest the facilities to add control devices because there's no any emissions to the outside. These in some cases in these cut and sew there's only ventilation, you know, so there's no need to add control devices in these facilities. But again, Higg index is asking you to add control devices. But for question 5, if I do not actually in question 5, I think it is indoor question or question 4. You probably use in cut and sew facilities spot cleaners, so you need to have control devices to increase indoor air quality. Also, particulate matter could be in the facility, in cut and sew facilities. So for indoor, yes, it's applicable for control devices, but for question 4, point source, yeah, I do not suggest you to add control devices for cut and sew facilities. Also, when you do all these things except question 4 and 5, you're not going to lose much points. You're going to achieve level 2 and 3. As a good practice, should we set a baseline before implementing modernization or post-modernization? Yeah, of course, yeah, we need to set always baseline. But I'm going to ask you after webinar to understand your point. For other chemicals other than solvents, I need to calculate emissions. If the chemical cause emissions, yes, you need to calculate the emissions for all chemicals. Laura, you can continue right now. That's all questions. We answered all the questions.
It was great that all of you had such great questions, and as Aladdin said, that if there is some more advice required, do not hesitate to reach out to us afterwards. Before we close, I have some more information to you about our offers. We offer training and verification in many countries, and we have been verifying in several of the countries listed here. So if you're interested in verification, please get in touch. Please begin planning and scheduling your verification early so that we can find the best dates for the verification for you, and you can post your verified results as soon as possible. In our experience, the month of October to December are very busy, so the earlier you plan, the easier it will be for us to support you. With this in mind, I would like to also recommend some of our previous webinars, amongst others from our verification trail that you might know by now, and more. So here we see an overview of all the sections that we did so far, and we also look forward to continue with the last 2 sections. So we invite you to do training and verification with us. If you're interested, please contact us. You can book a time with Karin directly online, or you can also send her an email, or if you're based in Turkey, you can also contact Aladdin directly, or in Bangladesh, you can contact Hafiz. And we have come to our final slides. Here you can see our growing team. There will be a survey with a few questions available after this webinar. We are honestly very grateful for your input, so please take 2 minutes to respond to the survey. And thank you for joining us today. See you soon and goodbye.